Look up. See that red dot in the night sky? That's Mars. It has fascinated us for centuries. Ever since humans first gazed at the stars, that reddish light has sparked curiosity. Why is it red? What secrets does it hold? The red planet has always been a source of wonder. Some imagined it as a fiery world, home to powerful gods. Others saw it as a desolate wasteland. Today we explore Mars with rovers and telescopes. We're piecing together the puzzle of its past. Join me as we uncover the science behind the red planet's striking hue. Let's journey back in time. The Egyptians called Mars Horus the Red, their god of war. The Babylonians linked it to Nergal, a deity associated with death and plague. Across cultures, Mars, with its distinct color, evoked strong emotions. It became a symbol of war, danger, and even passion. These early interpretations were driven by imagination. Mars does have a connection to iron, a metal often associated with war. The Greeks called Mars Ares, their god of war. These ancient cultures, observing Mars with the naked eye, built narratives around its fiery appearance. As centuries passed, observation gave way to more structured study. Ancient astronomers, particularly in Greece and the Middle East, began charting Mars's movements. They noticed its unusual path compared to other stars. Sometimes it moved forward, sometimes backward, a celestial dance that puzzled them. These early astronomers didn't have telescopes, yet they made surprisingly accurate observations. Their dedication to understanding the cosmos paved the way for our modern exploration of Mars. The invention of the telescope in the 17th century revolutionized our understanding of Mars. Galileo Galilei, a pioneer of astronomy, was among the first to observe Mars through this new lens. While his telescope was rudimentary compared to today's instruments, it allowed him to see Mars as more than just a point of light. Galileo's observations, though limited, sparked further intrigue. He saw phases of Mars, similar to those of the Moon, confirming it as a spherical body orbiting the Sun. As telescopes improved, astronomers could discern more details on Mars's surface. The red planet, once a mythological figure, was becoming a world of its own, ripe for exploration. In the late 19th century, Italian astronomer Giovanni Schiaparelli made observations that captivated the world. Using a powerful telescope, he created detailed maps of Mars, meticulously charting its surface features. These maps included what appeared to be a network of long, straight lines crisscrossing the planet. Schiaparelli called these lines canali, Italian for channels. This term, however, was often mistranslated as canals in English, implying artificial structures. This sparked widespread speculation about intelligent life on Mars, constructing irrigation systems to transport water across the arid planet. The idea of Martian canals captured the public imagination. However, as telescopes continued to improve, the Martian canals were revealed to be an optical illusion. Despite this, the idea of Martian canals left a lasting impact, inspiring generations of scientists and science fiction writers alike. The mid-20th century marked the beginning of the space age, ushering in a new era of Martian exploration. No longer limited to Earth-based telescopes, humankind could now send robotic emissaries to Mars, seeking answers firsthand. The Mariner missions, launched by NASA in the 1960s and 70s, were our first forays into Martian territory. Mariner 4, in 1965, provided the first close-up images of Mars, shattering any lingering hopes of finding canals or advanced civilizations. The images revealed a barren, cratered landscape, more akin to the Moon than a thriving planet. The Mariner missions shifted our focus from speculation to scientific investigation. The Red Planet, once a canvas for our imaginations, was now a real world, full of its own wonders and secrets waiting to be uncovered. So why is Mars red? The answer lies in a common element found right here on Earth: iron. Just like the rusty old bicycle left out in the rain, Mars gets its reddish hue from iron oxide, more commonly known as rust. But how did all this iron end up on Mars's surface? Imagine the early solar system as a chaotic construction site. Planets were forming from a swirling disk of gas and dust. This disk contained heavy elements like iron, remnants of ancient stars that had exploded long ago. These elements were the building blocks of planets, including Mars. Now, iron isn't naturally red. In its pure form, it's a shiny, silvery gray metal. However, when iron is exposed to oxygen and water, a chemical reaction occurs, creating iron oxide. Now, you might be wondering, how did the iron on Mars rust? Wasn't Mars supposed to be a dry and dusty planet? You're right, Mars today is a desert world with very little liquid water on its surface. However, billions of years ago, Mars was a much wetter place. Scientists believe that rivers flowed, lakes shimmered, and oceans might have even existed on ancient Mars. This ancient water, interacting with the iron-rich rocks on Mars's surface, provided the perfect conditions for rust formation. Over millions of years, this process created vast amounts of iron oxide, staining the Martian landscape with its characteristic red hue. The iron oxide dust, whipped up by Martian winds, became part of the planet's atmosphere. This atmospheric dust absorbs blue and green wavelengths of sunlight, scattering the longer, reddish wavelengths, further enhancing the red color we see from Earth. It's like adding red dye to water. The water takes on the color of the dye, and the more dye you add, the more intense the color becomes. Similarly, the Martian atmosphere, saturated with iron oxide dust, contributes to the planet's striking red appearance. Now imagine this, a planet-wide dust storm on Mars. These aren't your average dust devils. Martian dust storms can engulf the entire planet, lasting for weeks or even months. During these storms, the fine, rusty dust is lifted high into the atmosphere, creating a reddish haze that obscures the surface from view. These dust storms play a crucial role in distributing iron oxide across the planet. Like an artist blending paint on a canvas, the Martian winds carry the red dust far and wide, coating even those areas where rust formation might be less prominent. This explains why Mars appears so uniformly red, even though the concentration of iron oxide might vary across its surface. The dust storms act as a global homogenizer, ensuring that the red planet lives up to its name. But the influence of these dust storms extends beyond Mars's appearance. While Mars is known as the Red Planet, it's not a uniform rusty brown landscape. Spacecraft missions have revealed a surprising diversity of colors on the Martian surface, hinting at a more complex geological history than previously imagined. For example, some regions of Mars exhibit stunning shades of gold and yellow. These colors are often associated with sulfur-rich minerals, suggesting past volcanic activity and hydrothermal vents. These vents, spewing hot, mineral-rich water, could have provided environments suitable for life in Mars' early history. In other areas, you'll find dark, almost black regions. These are often composed of volcanic basalt, similar to the rocks found in Hawaii or Iceland. And let's not forget the polar ice caps, gleaming white against the reddish landscape. So, while the red color dominates our view of Mars, it's essential to remember that it's just one aspect of this fascinating planet. Beneath the rusty exterior lies a world of geological wonders, diverse landscapes, and a history that continues to intrigue scientists. Exploring Mars isn't just about finding evidence of past life or paving the way for future human missions. It's about unraveling the mysteries of a neighboring planet, understanding its evolution, and appreciating the sheer diversity of worlds that exist beyond our own. And who knows, perhaps beneath the red dust, Mars holds even more surprises, waiting to be discovered by future explorers and dreamers alike. Ever wondered what it would be like to breathe on Mars? Bad news, you'd need a spacesuit. The Martian atmosphere is about 100 times thinner than Earth's. It's like being at the top of a very, very tall mountain. You wouldn't survive long without a pressurized suit providing oxygen. And that thin air contributes to Mars's color. We've talked about the iron oxide, the rust, but that dust gets kicked up high into the atmosphere by Martian winds. It's like a planet-wide dust storm that never really ends. This dust absorbs some of the sunlight, particularly the blues and greens, letting those reds and oranges dominate what we see. Ever heard of a pink sky? Martian sunsets are often described as having a bluish tinge. A day on Mars is about 24.6 hours long, just a bit longer than an Earth day. We could adapt to that, right? But the temperatures. At the equator, a summer day might reach a balmy 70 degrees Fahrenheit. Sounds nice, but wait. As soon as the sun sets, temperatures plummet. We're talking about minus 200 degrees Fahrenheit in some places. That's colder than the coldest winter day on Earth. Those temperature swings are extreme, even for the hardiest robots we send there. And if you thought Earth had dust storms, Mars will blow you away, literally. We've mentioned that Mars was once a much wetter place, but how do we know that? Well, imagine looking at a photo of Earth from space. You see rivers carving through landscapes, deltas where rivers meet the sea, even ancient shorelines. We see similar features on Mars, but they're long dry. Orbiting spacecraft have sent back stunning images of canyons that dwarf the Grand Canyon. And those rovers we've sent, they've trundled along what were once riverbeds, even found minerals that form only in the presence of water. There's even water ice at the Martian poles. The evidence is clear. Mars was once a much more Earth-like place. Section 4. Volcanoes and canyons, Martian geography's extremes. If you love dramatic landscapes, Mars is the place for you. Forget Mount Everest. Mars is home to Olympus Mons, the tallest volcano in the solar system. It's 3 times taller than Everest and so wide that its base would cover the entire state of Missouri. And then there's Valles Marineris, a canyon system so grand it makes the Grand Canyon look like a ditch. It stretches for over 4,000 kilometers, almost the width of the entire United States. Scientists are still debating how it formed, with theories ranging from ancient tectonic activity to erosion by catastrophic floods. These massive features tell us that Mars has a dynamic geologic history. It's a planet that has seen a lot of action, from volcanic eruptions that would dwarf anything on Earth to ancient floods that carved out vast canyons. Imagine what else we might find as we continue to explore. The next giant leap human missions to Mars. Landing humans on Mars is the next giant leap in space exploration. It's a dream that has captivated humanity for decades. But getting humans to Mars and back safely is a monumental challenge. First, there's the journey itself. Mars is about 140 million miles away from Earth. A one-way trip could take 6 to 8 months. Then there's the issue of landing on Mars. The Martian atmosphere is thin, providing less drag for spacecraft. Landing a large spacecraft requires advanced technologies, and once we get there, we need to ensure the survival of our astronauts. Building a second home? The challenges and rewards of colonization. Some envision a future where humans establish a permanent presence on Mars, creating a second home for humanity. The idea of colonizing Mars is gaining traction, driven by concerns about Earth's sustainability and the human spirit of exploration. Imagine humans living and working on Mars, conducting research, mining resources, and building a new society. Establishing a Martian colony presents enormous challenges. The thin atmosphere provides little protection from radiation, requiring innovative solutions for shielding habitats and growing crops. Despite these challenges, the potential rewards are significant. It would provide a backup plan for humanity, ensuring our survival in the event of a catastrophe on Earth. It would also open up new frontiers for scientific discovery and technological innovation. Mars as a stepping stone expanding humanity's reach into the cosmos. Exploring and potentially colonizing Mars is not just about reaching a single planet. It's about developing the technologies, knowledge, and experience needed to expand humanity's reach further into the cosmos. Mars serves as an ideal testing ground for future missions to more distant destinations. Imagine using Mars as a launch pad for missions to the asteroid belt, the moons of Jupiter and Saturn, or even beyond. The lessons learned from building a sustainable presence on Mars would be invaluable for future spacefarers. Exploring Mars could provide insights into the origins of life itself. If life ever arose on Mars, studying its remnants could provide clues about the early evolution of life in the solar system. By pushing the boundaries of space exploration, we're investing in the future of humanity. We're inspiring future generations to dream big and reach for the stars. So there you have it, Mars, the red planet. Its rusty hue, visible across the vastness of space, tells a story. It speaks of iron, transformed by time and the elements, painting a planet red. But it's more than just a color. It's a beacon, drawing us onward. We've journeyed through history, from ancient myths to modern science. We've uncovered the secrets of Mars's thin atmosphere, its dramatic landscapes, and the tantalizing evidence of a watery past. And while we haven't found Martians yet, the search for life, past or present, continues to drive us. The Red Planet beckons. It challenges us to push the boundaries of technology, to dare to dream of living beyond Earth. It's a symbol of human curiosity, our relentless desire to explore the unknown. And who knows what wonders we'll uncover as we venture further, driven by that red light in the sky. One thing's for sure, the story of Mars, like the universe itself, is far from over.